So to solve the sun model, it didn't take very much mathematics after we spent several weeks trying to solve the lamp model, okay? So hopefully you guys and gals would agree that to solve the sun model, we have just a couple variables that are affecting the length of our shadow when it's produced by the sun. So you have an object outside, okay? Well, that object has a triangular situation here. I struggle with drawing triangles with my slate. Let me see. Let's do it real quick here. All right, so what we have is a right triangle situation because the object in the object outside is going to be standing or placed 90 degrees with the ground. So we have a right triangle situation. Well, the angle to the sun, okay, is going to occur at the bottom of the shadow. It's called the angle of inclination. And remember that when we have a missing angle, we call that a theta. We use x's and y's for the sides. So the height of the object can change at all times. So we're going to have that be h. And s again is our shadow length. Well, this angle to the sun, okay, it's going to be the same angle here if you were turned backwards looking towards the sun. And they are then corresponding angles because, as you know, the top of that person extended out could be a parallel line. Their eyesight straight out could be a parallel line with the ground. Well, with that being said, because this is a right triangle situation, would you agree that on a right triangle, if we were missing an angle and we have two sides that we're dealing with, we could use basic trigonometry. From this angle, what is h? It's the opposite side, okay? And what is s? Adjacent side. And so what trig function uses opposite and adjacent? Tangent. So the tangent of theta is going to equal the opposite over the adjacent, or the height of the object, divided by the length of the shadow. And our goal is to get shadow, the length of the shadow by itself. That's our variable. So if you recall, we could swap these two things, right? When the variable's in the bottom that we're worried about. So hopefully you would agree that the length of the shadow, drum roll, this is your second unit problem solution here, part 2. Shadow length is always going to equal the height of the object divided by the tangent of theta, or the angle of the sun where it's at in the sky. Dun, dun, dun. So very quick and easy compared to that lamp model that we were trying to solve first half. Okay? So some students, they're kind of surprised that the sun model, this idea that the sun is always moving, is simpler to solve than the lamp model where that light is at a fixed spot. Okay? So that concludes solving the sun model. So again, the shadow would always equal the height of the object divided by the tangent of theta, or the angle of the sun.